Hi everyone. Today let's talk about session 7.6, hypothesis concerning one mean. So today we're going to talk about the 5 steps of test of hypothesis. First step, we want to figure out the null hypothesis, alternative hypothesis. Second step, find the level of significance. And then third step, find the criterion. Determine the criterion, when to accept the claim, when to reject the claim. And then step 4, collect the data and calculate the mean, the sample mean, and then sometimes calculate the sample standard deviation. And then step 5, make the decisions. Okay? So today we're going to talk about how to determine the criterion. So we're going to have 3 cases: large sample size with no sigma. Okay? So let's look at the first case. Example 1. Claim the thermal conductivity of a certain kind of cement brick is 0.34. We would test on the basis of n equals to 35 determinations and at the 0.05 level of significance. So last time we talked about the level of significance is another name for the probability of type 1 error, alpha. Okay, from information from similar studies, we expect the population standard deviation is 0.01. If the sample mean from those 35 determinations is 0.343, shall we reject the claim? Okay, so let's look at the steps. So first step, what is the null hypothesis? So null hypothesis is usually the manufacturer's claim. Okay, so this is usually the manufacturer. Okay, claim. So far, so good. And then here the manufacturer's claim is population mean equals 0.340. And then the alternative hypothesis is usually the negation of that. So here, because here we have two-sided alternative hypothesis. So this is a two-sided alternative hypothesis. Sometimes, like our drying time example, if the drying time is smaller, is faster, then we're actually happy. So we have one-sided alternative hypothesis. Or if you have the amounts of chips in a bag or the amounts of Coke in a bottle, if we have more Coke or chips, we're actually happier. So we also have one-sided alternative in that case. So that's the first step. Determine the null hypothesis H0 and the alternative hypothesis H1. So determine whether it's two-sided or one-sided. Okay? So think about what make you not happy. Okay? Here we're not happy if the mu is not as described. Okay? When the mu is not equals to 0.340. Okay, step 2, level of significance. That's also the probability of type 1 error. Okay, that's alpha. So in this problem, we are at the level of significance 0.05. So alpha is 0.05. Step 3, let mu0 be the values of mu in the claim. So i.e. in our example, mu0 is 0.340. And then we have the z equals to the sample mean minus mu0 over sigma over square root of n. It can be approximated by the standard normal distribution. Okay, so here are the critical region for testing mu equals to mu0. Okay, so let me copy this. Sometimes words delete some of the letter. Oops. Okay. All right. So how do we determine? Okay. So think about here the null hypothesis. That's the manufacturer's claim. Mu greater equal to mu0. Sometimes maybe it just tell you mu equals to mu0. Okay. So let's look at our picture. So we have two pictures. So this picture, this is mu. Okay, so this is mu 0 and this is 0. Okay, this is x bar and this is z. Okay, z is the standardized sample mean. Okay, so here is talking about mu equals mu 0. So which means what make you unhappy? So you are unhappy if my mu is less than mu 0. Okay, so what make us unhappy? Okay. Well, if mu is very small, we are not happy, right? And the claim mu greater or equal to mu 0, so here we are happy because this is the manufacturer's claim is true. Okay, he didn't lie, so we are happy about that. So that's why this is the picture. Okay, so we if we transform into the other picture here, so this guy will tell us, okay, also think about what's the type 1 error? So alpha is the probability of type 1 error. Okay, so that's the probability of the claim H0 is true, but we reject it. Okay, so that is also the area of the reject region. Okay, so here we reject it if we're right here, right? So this is the reject region. Well, the area here should be alpha. Okay, so this area should be alpha. Well, then what is this number? So what's this number? Well, remember the z alpha is symmetric about the center, 0. So that corresponds to this guy. This guy is also alpha. We know if this guy is alpha, then this is z alpha. So then this guy is minus z alpha. So the critical region, okay, which is the area, so the region is when z less than minus z alpha. Okay, so if z is smaller than minus z alpha, we will reject it. Okay, so here we're looking for a reject region with area alpha. So the area equals to alpha. Okay, so that's the picture of when the alternate hypothesis is one-sided and it's mu less than mu 0. Okay, let's look at next picture. Let's make it colorful. Okay, so the picture we have the mu 0 in the middle, and this guy is the z, the standardized, so 0 is in the middle. Okay, so the null hypothesis is mu less than equal to mu 0. So less than equal to mu 0 is good. That's the manufacturer's claim, right? If the values here were happy. So if mu is greater than mu 0, we are not happy here. So this is our reject region. So the area of the reject region should be alpha. So far, so good. The claim is true. We reject it. So that's the area of the reject region. So if this is alpha, then this is z alpha. So we reject the null hypothesis if z is greater than z alpha. So far, so good. So we can always draw the picture and then figure out. Okay. So how about the third one? So the third one, let's use orange. Okay, we draw the picture. So this is mu 0. This is 0. Okay, so here the null hypothesis is mu, exactly mu 0. Okay, then we have a two-sided, so this is two-sided alternative hypothesis. Okay, it has to be mu 0. If it's not mu 0, I'm not happy. So I'm not happy here and here. I'm only happy when we're right in the middle. So far, so good, everybody. So that means, remember, we want to reject it when it's like this region, but the area of the reject region equals to alpha. Then what is the region of each of them? Well, each of them, so each has the area alpha over 2. Well, if this guy has the area alpha over 2, then this is z alpha over 2. Well, then this guy is minus z alpha over 2. So that's why we reject the null hypothesis if z less than minus z alpha over 2 or z greater than z alpha over 2. So far, so good, everybody. So that's the 3 different cases. It really depends on the alternative hypothesis. So it depends on the alternative hypothesis. It does not depending on these signs, okay? Because the manufacturer's claim can just tell you, okay, the drying time is 20. Well, then you cannot say, oh, it's 20. That is the third one. So we use two-sided. No. Even though it tell you it's 20, but you think about what make you happy or not happy. Okay? You're happy if the drying time is less than or equal to 20. Okay? You're not happy if the drying time is over 20. So then we are in this case. So far, so good. So we reject the claim if z is bigger than some number, z alpha. Okay? All right. So here in our example, alpha is 0.05. Okay? Then the critical values are plus or minus z alpha. So z 0.05. Last session, we talked about that. So z 0.05, we can look at our t table. So the last row of the t-table is the z alpha values. So 0.05 is the second column, so 1.645. Okay, and z alpha over 2. So z alpha over 2 is z 0.025. So 0.025 is right here, the third column, so 1.96. If alpha equals 0.01, the critical values is z 0.01. Z 0.01, let's look at our table, is 2.326, okay? And here I round to 2.33, but if you wanted to more accurate, so that's 2.326. Okay, and the z alpha over 2 is z 0.005. 0.005 is 2.576. 2.576. So these numbers are more accurate, okay? So in our example here, we have two-sided alternative, okay? Because remember the alternative hypothesis is mu not equal to 0.340. Okay, so we have a two-sided alternative. So we reject, so this is our criterion. We reject the null hypothesis if z less than z two-sided, so we use this guy. Okay, so we use this guy. So minus z alpha over 2. Alpha over 2 is z 0.025. That is 1.96. So our criterion is we reject the null hypothesis if z is less than minus 1.96 or z is greater than 1.96, where z equals to the sample mean minus the population mean as the claimed over the population standard deviation divided by the square root of n, sample size. Okay, step 4, calculation. So because we have suppose we have the sample mean of the 35 determination is 0.343. Well, then let's plug in 0.343 minus 0.340 over 0.01 over square root of 35 Plug this in your calculator. You get 1.77. And where's 1.77? Remember, now our region is okay, so our region here, negative 1.96, 1.96. Here we are happy, and here we are not happy. So 1.77 is actually within the happy region, so we fail to reject the claim. Okay, so we fail to reject the null hypothesis. Remark. So our conclusion is not proving the null hypothesis. We just fail to reject it. Okay, so maybe you want to take another sample and to calculate if a couple samples shows that they fail to reject the null hypothesis. Maybe we can believe that the manufacturer's claim is true. Okay. So far so good, everybody. Alright, so I hope you can pause the video and try to work on this problem. Okay, after you're done, we can check our answer together. Are you done? Alright, so let's check it together. Okay. Surface hardness measurements of the vinyl flooring produced has a normal distribution with mean 4.5 and standard deviation 1.5. A new shift has been hired and trained, and their production needs to be monitored. Consider testing the null hypothesis. Oh, so it tells the null hypothesis. So the alternate hypothesis is a two-sided. A random sample of hardness measurements is made of 45 vinyl specimens produced by the new shift. If the sample mean is 3.9 at the 0.05 level of significance, what can we say about the new shift? Is it good or bad? Okay, so let's look at the steps. Well, so I hope you can write down the steps, the 5 steps. So you don't have to say step 1, step 2, but at least point out 1. Okay, step 1. So 1. The null hypothesis mu equals to 4.5, and the alternative hypothesis is mu not equal to 4.5. So far, so good, everybody. That's the first step. Determine the null hypothesis and the alternative hypothesis. Okay, and here we have a two-sided alternative. Okay, step 2. We want to find the level of significance. What is the level of significance? Okay, we have alpha equals 0.05. All right, so that is step 2. Step 3. What is our criterion? Okay, our criterion, look at this. So, okay, so here our picture is two-sided, right? So mu 0x. So if two-sided means if it's in the middle, we are happy. If it's outside, then we are not happy. Okay, so not happy here. And the area of the reject region is alpha. So this guy is alpha over 2. Then this is z alpha over 2. This is minus z alpha over 2. So we reject the null hypothesis if z is less than minus z alpha over 2, or the z is greater than z alpha over 2. So far, so good. And what's z alpha over 2? Well, z alpha over 2 is z alpha is 0.05, alpha over 2 is 0.025. And from our table, if you can remember, z 0.025 is 1.96. So far, so good. Okay, that is our criterion. Step 4. Well, step 4, we're going to calculate. So z is x bar minus mu over sigma over square root of n. X bar is Let's say the sample mean. See, the sample mean is 3.9. So 3.9 minus mu. Mu is 4.5 over sigma. Sigma is 1.5 over square root of n. N is 45. Okay, so plot this in our calculator. Alright, so parentheses 3.9 minus 4.5 parentheses divided by 1.5, then times, because you divide it and divide it by square root, it becomes times square root of 45. So I hope everybody practice how to type this in your calculator, because it's not trivial. Okay, so I got negative 2.68. So far, so good, everybody? Okay, so, and what happened now? So, we reject it, okay, because we reject it. We reject if z less than negative 1.96 or z is greater than 1.96, and this guy is smaller than negative 1.96. So step 5, what is our decision? Okay, our decision is reject the claim. Okay, so reject H0. Okay, so which means the new shift needs to change again. So far, so good, everybody? So this is how we calculate. Okay, so let's continue. Well, this is the first case when we have large sample size and we know sigma. Second case, when we have large sample size and we don't know sigma. In this case, the criterion is very similar to what we have done. Okay, the only change is we don't have sigma, so we use the sample standard deviation to calculate. Okay, and the critical region, this table stay the same. All right, let's look at example 3. So please work on example 3 first, and then continue the video and check our work together. Okay, example 3. A trucking firm is suspicious of the claim that the average lifetime of certain tires is at least 28,000 miles. The firm put 40 of these tires on this truck and get a mean life of 27,463 miles, with a standard deviation of 1,348 miles. What can it conclude if the probability of a type 1 error is to be at most 0.01? Okay, so follow the 5 steps. First step, if you don't want to write the step, it's okay, but you at least number the steps. Okay, so first step, what is the null hypothesis? Well, manufacturers claim the mean time is at least greater or equal to 28,000. Okay, and our alternative hypothesis is less than 28,000. So here we have one-sided alternative. Okay. Step 2. What is the type 1 error? Well, type 1 error is at most 0.01. Okay. And then 3. What is the critical region? Okay, so let's draw a picture here. So this is X bar, this is Z, this is mu 0. Okay. I draw them so close. Okay. Let me draw them. Okay, Z. Okay, so think about it. If mu greater or equal, so if the lifetime of the tire is greater than 28,000, we are happy, right? So if here we are happy. And when it's small, okay, your tires breaks so soon, then we're not happy. Okay. So we're not happy here. So this picture is the same. Okay, this is a Z, this is 0. And we're not happy here. Happy here. Okay, so the not happy area is alpha. So this is alpha. Well, then the corresponding is this guy is alpha. So we know this is Z alpha. Then this guy is minus Z alpha. So we reject H0 if our Z is less than minus Z alpha. So far, so good, everybody? Okay. What's Z alpha? Well, Z alpha is Z.01. What's Z.01? Well, let's look at our table. Alpha is 0.01, then 2.326. 2.326. Okay, where am I pointing? Okay, so far so good, everybody? Okay, so, and then step 4, we're gonna calculate. Okay, so Z is x bar minus mu over sigma over square root of n. X bar is 27463. Mu in the claim is 28,000. Sigma. Oh, remember we're in case 2. Case 2, we don't know the population standard deviation. We know the sample standard deviation. S is 1348 over square root of n. N is 40. Okay, so plug this in our calculator. What do we get? So we have 27463 minus 28000 divided by 1348 times square root of 40. Okay, so I got negative 2.5195. Okay, let's see. Oh, you can see this guy is less than negative 2.326. Okay, so we're right here. So, which means reject the claim. Okay, so reject the claim. So far, so good? Okay, so we can say reject claim at the level of significance 0.01. Okay, at the level of significance 0.01. Okay, so that is example 3. The 5 steps. Okay, case 3. Small sample size and normal population with unknown sigma. Okay, similar steps, but we need to use sample standard deviation to approximate the population standard deviation. And we also consider the t distribution instead of z. Okay, so we have the t distribution. The degree of freedom is n minus 1. Okay, it's not n minus 1. Okay, so for the critical region, we still have the almost the same, just replace z by t. Okay, so how about use green? Okay, so just replace z by t. Okay, example 4. A specification of a certain kind of ribbon call for mean breaking strength of 180 pounds. If 5 pieces of ribbon have a mean breaking strength of 169.5 pounds with a standard deviation of 5.7 pounds. Test the null hypothesis mu equals to 180 against the alternative hypothesis mu less than 180 at a 0.01 level of significance. Assume normal population. Okay, the 5 steps. Step 1. What is the null hypothesis? The null hypothesis mu equals to 180 and the alternative hypothesis. So here, even though the null hypothesis is mu equal, and then the alternative hypothesis is not like the negation of that, is actually mu less than 180. Because if the string is bigger, we are actually happier, right? We are actually happy. So we're not happy if the string is not as described. Okay, so here we have one-sided. So I really want you to emphasize we have a one-sided or two-sided alternative because the critical region can be quite different. Okay, step 2. What is step 2? Do you remember? Level of significance. Alpha equals 2.01. Okay, so 0.01. Let's see here. 3. What is the criterion? What's the criterion? Well, let's draw a picture. So you see, I don't need to memorize the table. I draw a picture. When you're happy, when you're not happy, then we can figure out the critical region. We don't need to look at the table, right? So let's see. Draw the picture. This is x bar, mu 0 is in the middle, and this is z, then we have 0 in the middle. Okay, so it claims that mu 0 is 180, and when it's bigger, we are happy, right? Bigger or equal, we are happy because it's strong. I can, it's not easily to break. Okay, so, and then here, oh, we're not happy. So far, so good, everybody. So that's why here we are not happy, and that area is alpha. Well, that corresponds to, if this is alpha, this is z alpha, then this is minus z alpha. So we reject, oh, I'm sorry. What did I miss? This is not z, this is t. Okay, we use small sample, so t distribution. Okay, so we reject if t less than minus t alpha. Okay, so here what's alpha? Well, alpha is 0.01, but what is the degree of freedom? What is n? N is 5. Okay, n is 5, then degree of freedom is n minus 1, which is 4. Okay, so then let's look at our table. So table 4, t table. Nu is degree of freedom is 4 and 0.01. 4 and 0.01. So 3.747. So negative 3.47. 747. Oh, okay, 747. Okay, that is step 3. Figure out the criterion. Step 4, calculate. So t equals to x bar minus mu over s over square root of n. X bar is 169.5. And then mu is 180. S, what is s? 5.7 over square root of n. N is 5. Okay, let's put it into our calculator. 169.5 minus 180 divided by 5.7 times square root of 5. Okay, that is negative 4.11907, so 1. Okay, what happened? Oh, this guy is less than negative 3.747. Yeah, so this guy is less than negative 3.747. So what is our decision? Reject. So reject the claim. Okay, so reject the no hypothesis at the level of significance 0.01. Okay, so that is the 5 sets of test hypotheses. So far, so good, everybody. So once we understand the process, then it's not that bad, right? So, but you always need to think, okay, that's the manufacturer's claim. What make you not happy? Okay. And sometimes you really want to understand the problem to think about the actual situation. Like here, mu is 180. So even though the problem don't tell you to find the alternative hypothesis, okay, I can just delete this sentence and then you have to figure out, well, the breaking strength, if it's bigger, are you happy? Yeah, so it's stronger rebound, right? So if it's small, we're not happy. So that's why we can still figure out without this sentence, we can still figure out the alternative hypothesis is mu less than 180, which is one-sided. And then this will change our critical region. So far, so good, everybody. And also, keep in mind there are 3 cases: large sample, okay, no sigma, or large sample but we don't know sigma, then use the sample standard deviation S to calculate. Or we have small sample means the sample size is less than 30, okay, then we use the t distribution to calculate. All right, so that is session 7.6. Bye.